Hello, everyone, and welcome. My name is Lorna Kanyede, and my co-author is Lei Chen from the College of Engineering and Computing, Georgia Southern University. I'm happy to present the paper, A Hybrid Risk Assessment Technique for Data Center. This paper is presented at the 2024 International Conference on Security and Management. This is a preview of today's presentation. We will go through the abstract that gives us a preview of what the paper is about, an introduction which gives us the background, literature review for the authors who have contributed to this research paper, the problem statement, methodology that was used to create the hybrid framework. We shall evaluate the results and discuss our findings, and finally conclude on the hybrid risk assessment framework. Information security is important to an organization's overall security. Software systems that contain this security are faced with great risk. It's therefore important to tightly couple the risk assessment techniques with vulnerable assessment and penetration techniques. The research will focus on evaluating the different assessment techniques that are specific to data centers. These are the event tree, the fault tree, the incident and bowtie, comparing the strengths and weaknesses of each proposal so that we are able to develop a very robust hybrid framework that will overcome the challenges presented by each risk assessment technique. Risk is generally understood as the possibility of loss or injury. Risk is the uncertainty that an event may occur. It can be positive and it can be negative. A positive risk creates an opportunity, while a negative risk may lead to a threat. So negative risks may require a risk mitigation plan in place. So risk management is the process of identifying these risks. We have techniques like the fishbone analysis and the Pareto, analyzing these risks, evaluating these risks through risk matrices and risk indices, and being able to treat these risks through methods like barrier analysis and cost-benefit analysis. So the main elements of risks are the risk event, the risk factors, which are the issues that give rise to the risk. We have the risk tolerance and the risk probability, which is the likelihood of the risk occurring, and the risk impact, which is the effect of the risk event. Management process can be summarized in 4 major steps. So we have the risk identification, where we are discovering all the factors that may lead to system unavailability in the data center. We have risk assessment, where we identify the level of exposure of the risk event. So the focus here will be on the impact and likelihood of the risk. Events with high likelihood and impact are given priority, and the consequences of the risk is assessed at this stage. So here we have example of the fault tree analysis, the event tree, and the hazard and operability analysis. Then we go over to the risk mitigation, which are the actions that are taken to avoid and prevent the risk from occurring. So here the risk can be avoided, accepted, mitigated, or even transferred. Finally, the last step is the risk conclusion, where we give a summary of the actions of reducing and avoiding the risk. The risk assessment technique used for this hybrid framework is the fault tree analysis and the event tree. The fault tree analysis uses a top-down approach to analyze and estimate the system failure, beginning from the top event right here to the middle event right here represented by a rectangle, to the bottom or the basic event represented by a circle. These events are connected through a cause and effect relationship using logic gates. The main disadvantage is that it only majorly uses the cause-oriented and lacks the aspect of analyzing the consequences related to the given event occurring. So the event tree, on the other hand, develops a viable scenario for reaching the risk event. The activation can either be a success or a failure, which protects the measures against the specific initiating event and the subsequent event. So the disadvantage we have here with the event tree is that it only focuses on the consequences. Here we have literature that was used to understand the risk assessment techniques that are going to be applied in developing the hybrid framework. We have Berman, who used rule-based knowledge for diagnosing and forecasting the states of complex technical system by use of the event tree. We have Zhao, who increased the efficiency of the manufacturing process by using the fault tree analysis on tray loader's machine on power battery. We have Parba, who focuses on using the event tree analysis for calculating the core damage frequency in nuclear plants. And then we have Accuse, who focuses on using the fault tree and the event tree on the risk of cargo liquefaction on board ships. The idea is to be able to enhance the safety awareness about cargo liquefaction on the board ships. Yang and Lee used the bow and tie model to do a safety risk analysis in railway traffic by identifying the cause of a railway accident using an accident report. The causation and consequences for the report are then summarized, and factors of the accident identified and preventative measures are provided. Hashemi focuses on utilizing the approximate computing to mitigate the fault tree analysis simulation time while considering accuracy, efficiency, and power consumption. Liu and Yokoyama are able to use the fault tree analysis in order to increase the effectiveness of the team skill. It is very clear that risk assessment is an integral part of the risk management process. Using a specific risk assessment method may be disadvantageous as one is limited to the functionality of that framework. So this paper focuses on developing a robust hybrid risk assessment framework used in assessing system unavailability in data centers. So the objective is to be able to compare the strengths and weaknesses of risk assessment techniques, evaluate their efficacy, develop and implement the hybrid framework to provide the potential countermeasures against systems unavailability within the data center. The methodology used to create the hybrid risk assessment framework was developed by combining the event tree and the fault tree. This is because the event tree focuses on consequences and the fault tree focuses on the cause of the hazard. The framework was applied to United Network, an IT service and consulting company, as a case study, and was used to analyze the cause and consequences of system unavailability in the data center, and therefore able to prevent and mitigate those risks. So it was a four-step process where we were able to first construct a fault tree, secondly, construct an event tree, thirdly, construct a risk assessment survey to supplement the hybrid framework, and finally, construct the proposed hybrid framework. So in constructing the fault tree, it involved the following steps. So we first outlined the system to be analyzed. We were able to then determine the top event, which was the system unavailability in the data center. We identified the causes of the top level event. We identified the cause and the top event using logic gates like and or. And finally, we analyzed the built fault tree. The event tree was constructed using the following steps. So first, we were able to define the system. We were able to identify the initiating events, then the intermediate events. Then we were able to develop the event tree. Once we were able to do that, we identified the outcome risk related to system unavailability in the data center. Then we evaluated the probability of the outcome, and then we defined the possible countermeasures. A risk assessment survey was constructed to complement the hybrid framework. This was developed using Qualtrics. It was conducted within the IT department of United Networks. In addition to this, data was collected using the SAP ticketing system, and this data was analyzed. So the risk assessment survey covered three major sections. We have the major causes of system unavailability in the data center, the risk, likelihood, and impact, and the effectiveness of the incident response plan and mitigation strategies. Here we have the results of our fault tree analysis for the data center. Here we have the top event that was identified as the system unavailability in the data center. Then we have intermediate events that are represented by rectangles. So the immediate, intermediate events that were recognized for system unavailability in the data center are the hardware failure, the cyber attack, the software failure, the environmental factor, the human errors, and external factor. The events could further be broken down. So we have the power supply and the network hardware failure. Under the power supply, it was broken down again using an OR gate where we have the power outage, or we have the power surge or spike. The power outage could be further broken down into three basic events using an AND gate. So we have the UPS failure, the utility grid failure, and the generator failure. Once these three events occurred, it would result to a power outage. Under the power surge, we had the UPS failure and the generator failure. For the network hardware failure, we had the failure network equipment that was identified, the construction error, and the resource exhaustion. Resource exhaustion in the network was further broken down to be as a result of having an out of CPU memory and low hard disk space. Under the cyber attack, we had events that were broken down and identified as lack of having a layer 3, lack of security updates, lack of hardening servers and security patches, lack of security patches and antivirus updates. Under the software failures, we had the compiler warnings, the lack of continuous integration, and lack of code reviews. Under the application software bugs, was lack of regression and smoke testing, and having no monitoring software for errors. The environmental factors were failures to the system, cooling system, and the fire and water damage. Resulting to the human error, the basic events were the misconfigurations that happened within the network, having unauthorized access to the data center, and inadequate training of the staff. Finally, for the external factors, we have natural disasters like the earthquakes and flooding, And then finally, we have third-party service failures like the internet service provider. Here we have the results of the event tree that was constructed. We were able to develop scenarios for us to reach the risk event, which is system unavailability. The action or the activation could be either a success or a failure to render the protective measure against the specific initiating event and subsequent event. If we are to see this, we have the system unavailability we did of a frequency of a 2-year span. And then once we have network redundancy as a result of a success, we had calculated the probability of 0.9, while the failure was found to be 0.1, where we lacked network redundancy. And then being able to monitor software and doing preventative maintenance, we had a probability of 0.8, while that of a failure of 0.2. Then we have the IPS and intrusion detection systems, firewall security patches, and doing updates and audits surrounding. Once that was done, we had a success of 0.7, while we had a failure of 0.3. Then being able to do software updates, addressing operating systems and applications, software bugs. The success was found to be 0.75 and the failure to be 0.25. Now, the events of having a success in every of these scenarios would lead to system availability in the data center, while having a failure within a certain scenario would either lead to a system outage in the data center, the system crash, a security breach, or system misconfiguration. Now, the probability was calculated from the frequency multiplying the probability through every step. So if it's system availability in the data center, we have the frequency times the success of 0.9, 0.8, 0.7, 0.75, and we found that as 0.756. And this was done consequently for the others. Here we have the hybrid framework that was developed. We have the fault tree for data center and the event tree for the data center that was combined. So we are able to see a cause and effect relationships. The items needed to be prevented that cause the system unavailability is the hardware failure, the software failure, cyber attack, environmental factors, human factors, and external factors. While the items that needed to be mitigated is the service outage, the system crash, security breach, and system misconfiguration. Now, using this method, we can see that we are able to identify the critical control measures and mitigation barriers that were lacking in preventing system unavailability in the data center. So the major advantage of this hybrid framework is that it provides a comprehensive risk analysis so that the United Network can be able to do a comprehensive overview of what are their threats, what are their top events, the consequences, and the barriers. Here we have the results of the risk assessment survey and data collected from the SAP ticketing system. The systems that were highly affected was the customer service, while the major causes of system unavailability was software failure, cyber attacks, and network issues. Looking over to the impact, the events that had the highest impact or severe impact were the hardware failures, the software failures, the cyber attack, and the network issues. While those with the highest likelihood was the software failures, the cyber attacks, and the network issues. The risk mitigation strategies for cyber attacks was having a multi-factor authentication and a rule-based access control, being able to update security patches, implementing intrusion detection systems and SIM tools, and updating antivirus and malwares. Under the software failures, we had implementing version control, having code reviews, continuous integration, and utilizing softwares for error monitoring in regards to addressing compiler warnings. Under network issues, we were able to ensure that the network devices had the most recent firmware drives and software updates in order to be able to fix the bugs, compatibility issues, and having a network monitoring system to monitor the health of the environmental factors, power outages, and human errors had low impact, and this was due to the adoption of the HVAC systems, the flood control systems, and having a redundant power supply. Aside that, they had a cloud backup and a very well-trained staff. So the hybrid framework that was adopted to United Networks reduced the incidences by 40%, and this was indicated by the SAP ticketing system. In conclusion, the hybrid framework can be thought of an analytical method that applies the fault tree analysis to examine the root cause and the event tree to study the implication of the system unavailability. And then the two are results to a cause and effect hybrid framework. It's highly scalable and is able to eliminate the drawbacks of having a standalone event tree or fault tree. Future works can be seen when incorporating more risk assessment techniques like the fault mode effect analysis and hazard and operability analysis. Finally, we have the references that were used for the research. Thank you.